In this second example, instead of saying simplify, the actual instructions are there. Write each expression as a single logarithm. Now the difference in example 2 from example 1 is now you can have some of your log laws combined. So in the first one, we've got log x plus 3 log y. Again, you want to take stuff on the left-hand side, and we want to write it as a single, take stuff on the right-hand side and write it as a single logarithm, which is changing it to the left-hand side of all your formulas. So the first thing most people see is they see a plus sign. And they say, hey, I'm adding logarithms. I want to use the first one. But notice on the right-hand side of the first one, it only works when it's 1 log plus 1 log. And we have 1 log plus 3 logs. So we can't use our first log law yet because it only works if it's a log plus a log, and we have a log plus a 3 log. If we could get rid of that 3 somehow, it might be able to help us. So we look further on our list and we see, well, I have a number in front on the last one, and I can put a number in front in as an exponent. So if I do that, that'll move that 3 in as an exponent, and I'd have log x plus log y cubed. And now I have a log plus a log. So now I could use the first log law and say a log plus a log is the same as multiplying inside. If you'd like to put that in brackets, you can, but you wouldn't need to. And so now we've written it as a single logarithm. Part B. Log x plus 2 log y minus 4 log z. Now we have adding and we have subtracting, so that should trigger those first 2 log laws. But again, even the subtracting one only works if it's a log minus a log. And here we have numbers in front. So one of the things that you're going to see sort of as a pattern is when you're trying to simplify or when you're trying to combine as a single logarithm, you're going to always want to use your power law first and put any number that's in front of a log inside the logarithm as an exponent. So a very first step will always be if you put the entire negative in as a -4, then that would become a plus sign and it would still work. Okay? But generally we just put the number in front and keep things positive or negative. Okay? At this point, we've got a log plus a log minus a log. You've got a couple of log laws that you could put together. And the order really doesn't matter. I'm going to go from left to right. If I do log x plus log y squared, adding those together would be multiplication. Can you see that you would get log xy squared? And I still have minus log of z to the power 4. And now that I'm subtracting a log minus a log, that's going to be dividing, so we'll have xy squared over z to the 4. Be the same thing. So one of the things that you're probably, well, I don't know if you're thinking about right now or you're just like, whoo, we are doing some abstract stuff with something I don't really understand and I don't know why we're doing it. And that's okay, because I'll tell you right now what we are doing with the first 2 examples. We're practicing combining things as a single log. Our next 2 examples are going to be practicing expanding it. Expand, contract. Like, why are we doing all of this? Well, it's leading towards solving for x. And we need to have our skills with our logarithm laws really, really good in order to solve for x. We'll have some equations where you have to solve for x in an exponent. And when you're solving for x in an exponent, you're going to need to expand things completely in order to be able to do that. So skills in expanding things are going to be super important. And later we're going to solve for x inside of logarithms. In those questions, you have to be able to combine things as a single logarithm in order to solve them. So right now we are just building skills. Now it's hard to build skills at this point because you don't really understand logarithms very well yet because you haven't had much practice with them. And now you're using laws on them that you don't really understand and just sort of doing things. So it's hard just practicing. But I'm telling you the reason we're doing this is so that when we get to our solving questions, which is sort of the key point of this unit, you'll have the skills to do that. I'm going to add one in before C. We'll call it B.5. There we go. You don't have this, but we're going to just add a question, and we're going to say, is there a way that I can make things easier if I had log A plus log B minus log C minus log D, minus 3 log E? If I have a whole bunch of them, is there a way that I can work with these a little bit quicker? Like, how do I know that I can go right to this that quick? Well, one of the things you can do when you're combining a lot of logs with adding and subtracting is you know that adding with the log law is multiplying inside, and you know that subtracting with the log law is dividing inside. So when you have a string of logs that you want to put together, whichever ones are positive, they're going to end up in your numerator because they're going to get multiplied together. So you see the log A and the log B? That would get combined together and be multiplied, so you have A times B. All the ones that are subtracted, well, they're all going to be divided in the end. So instead of trying to do one at a time and getting confused and possibly making a lot of errors, can you see that the C, the D, and the E are all subtracted? So as a mental note, the first thing I did is I said, I'm going to put this 3 in as an exponent. That'll give me an E cubed. Then whichever ones are added, the A and the B went in my numerator. And all the other ones, the C, the D, and the E cubed, would go in my numerator. And that allows you to do things quicker. As far as showing your work on an exam, I would maybe do the 3 as the exponent first and show that one line. And then you can go directly to what's added and what's subtracted as a final answer. Sometimes if you don't show that one step and you make a mistake, they might give you 0 marks. So it allows you to show one step. So for example, in B, now that we look at B, I would do this first step by putting the exponents in. And then can you see how you could go from here right to there? The x and the y squared are added. They're going to get multiplied together in your numerator. The z to the 4 is subtracted, so that's why it's in your denominator. And you can skip this step of having to do one thing first and then the second thing. In part C, whoa, that scared me. In part C, we want to combine this as a single logarithm, but this is just a number. I have log 2 of 6 minus 3. Can I just do the 6 minus 3? No. The 3 is not inside that function. The only thing I know how to do is if I'm subtracting logs. And the only way you can subtract logs and put them together is if the bases are the same. So my question is, could I write this 3 as log 2 of something? What would I have to put here to make this equal to 3? If I put 1.5, is log 2 of 1.5 equal to 3? Again, what do logs solve for? Logs solve for an exponent. So we want the exponent to be 3 is 2 to the 3 equal to 1.5? what would have to go there so that it's equal to 3?
8.
An 8. Is 2 to the 3 equal to 8? Yes. So what I just did is I changed my 3 to a log of base 2. And now that it's a log of base 2, can I put those together? Yes, log minus a log is equal to 6 divided by 8. And you could reduce that to 3/4, or you could just leave that as it is.
And you can convert the other one just to a number and you get the same answer either way.
If you did it on your calculator, it would get the same result. So questions for this one, and I'll give you some time to work on these now. 5, 8, 11, and 18.